Today, we're going to be looking at how to balance out chemical equations. So the first thing I want you to do is to separate your reactants and your products. And the way I like to do it is to draw a line directly underneath my arrow because that's what separates my reactants from my products. And the first law of conservation of mass tells us that mass is neither created nor destroyed. This means that the amount of matter that you have in the beginning of your reaction is the same amount of matter that you will have in the end of your reaction, so your products, which is why balancing chemical equations is so important. You must have the same amount of things in the beginning as in the end. So what I like to do is to break down my compounds into what elements I have. So we have carbon, hydrogen, and oxygen, and we have carbon, hydrogen, and oxygen. So let's start with my reactant side first. In my molecular chemical equation, I have 1 carbon, 4 hydrogens, and 2 oxygens from these subscripts over here, and there's technically a coefficient of 1 for the carbon. Now let's do our products. We have 1 carbon, 2 hydrogens, and 3 oxygens. I have 2 oxygens here and 1 here, and then I have 2 hydrogens here, and then an invisible coefficient of 1 for my carbon. So my carbons are balanced out, but everything else isn't. What I like to do is start with my highest number first. So I have 4 hydrogens on my reactant side, but only 2 hydrogens on my product side. So what I'm going to do is write a coefficient of 2 in front of my H2O, because then this 2 multiplied by this subscript becomes 4. So I can cross out my old 2 and write that now I have 4 hydrogens. So now my carbons and my hydrogens are balanced. And because I wrote a coefficient of 2 in front of H2O, this 2 gets applied to this entire compound. So that means that instead of having 3 oxygens now, I have 4. Because I have 2 here and 2 here. So now, how do I get my oxygen on my reactant side to equal my oxygen on my product side? Well, I can write a coefficient of 2 in front of the oxygen, as we did here, because 2 times this would give us 4. So now let's recount. We have 1 carbon here, 1 carbon here, 4 here, 4 here, and 4 here, 4 here. So this follows the first law of conservation of mass, and we have equal amounts on our reactants and our products, so we know that we're done balancing. And you don't have to leave these empty, you can just write a coefficient of 1. But it would be the same thing as leaving it empty, but I would suggest writing a 1 either way. So let's do another one. So we have 8 carbons, 18 hydrogens, and 2 oxygens. And our product side, we have 1 carbon, 3 oxygens, and 2 hydrogens. So again, let's start with our biggest number. Our biggest number is 18, and what these two can share in common is that 2 times 9 will give us 18. So what we can do is put a 9 in front of this H2O here. And now, this 9 multiplied by this subscript of 2 will give us 18 hydrogens. But now this means that we have 9, 10, 11 oxygens. So let's leave our hydrogen and our oxygen as is for now and see what we can do with trial and error. So we still have to balance out our carbons. We have 8 on our reactants and 1 on our products. So what we could do is just write an 8 over here, and this will become 8 carbons. And now we recount our oxygens. So we have 16 on this side and 9 on this side. And that means that we have 25 oxygens. So everything seems to be balanced out except for our oxygens. And hypothetically, the easiest thing that you would think to do is say, well, okay, I have 2 here, 25 here. Maybe I could do something with 50, so 25 here and then 50 here, which you could do that technically, but it would require a lot of tweaking and you would have to switch a lot of these coefficients. The easiest way that you can go about this is doing a fraction. So what you would do is have your biggest number as your numerator, your smallest number as your denominator. And that would look like this. And when you do 25 over 2, you get 12.5. So technically, your coefficient is 12.5, and your subscript is 2. So when you do 12.5 times 2, you get 25. And that evens out your oxygens. And it's as simple as that. Try not to overthink it. Your final step could be to write a 1 as a coefficient here, and you could do either this fraction or the 12.5, same thing, and this is your final answer.